started and the recording is also going to be started. Okay. So here it is. Today we are going to start about a networking basics. Okay. So what is a network? What is a network? Look at here. I have a PC and if I'm using this paintbrush, I don't require network, right? So I'm communicating to my PC with my PC applications only. Okay. So I don't require any network connectivity for this. But in case you want to share information, okay, or you want to share a resource, or you want to share some what is we can say like a mail. You want to send and receive a mail for sharing information. Okay, to share information or to share resources, we need a network. Okay, so first of all, to share information means you are communicating to other devices. It means the first thing is important is we should be create a network. Okay, for example, these are the devices A1, B1, C1 are the devices are connected are connected. So connecting two or more devices, interconnection of two or more devices called a network. Okay, interconnection of two or more devices called a network. What is meant by networking? It is communication between two or more networks. Communication between two or more networks. Communication means, for example, you want to share information, means share a folder. You're sharing a folder so other PC can able to access that files. Or maybe you're sharing a printer, or maybe you're sending some instant messages. Okay, or maybe you're sending a mail. So it is means communication. You are sending and receiving information. Okay, that is what it is. Communication means communication between the two or more devices is called a networking. Interconnection of two or more devices is called a network. The communication between two or more interconnected devices called a network. What is this internetwork? So this is a one network, and you have a different networks. Maybe is near to the location or maybe far to the location. You have a different networks. I'm in a network, you are in the network, like that. Okay. Interconnection of two or more devices is called a network. So this is a network. But this is another network. Okay. Another network. So how to connect different networks? So with the help of internetworking device. With the help of internetworking device. For example, this is a network is connected to a router. It is a nothing but a internetworking device. Okay. So now I make a connectivity between different network. This is a network 1 and this is a network 2. So I make a connection between these networks. Okay. So how it is? Now it is internetwork. What is the internetwork? connection of two or more different networks called the internetwork. And what is the internetworking? Communication between two or more networks called a internetwork. For example, B1 is in this network, want to communicate it to A2 in this network. How they can able to communicate? So first of all, if the packet is goes to this switch or a hub, which is actually we create a network from that one, and the packet has to go to the router for our outer device, and it has to be reached to the router which is in the other network, and it is going to be reached to there. Okay, from here to here, then from here to here, then from here to here, from here to here, it will reach. Okay, so one network to another network communication. What is internetworking? Internetwork, it is a connection of two or more networks. What is internetworking? Means communication between different networks. I'm in a network, I'm communicating to you in another network. How? Because internetworking concept using a different routers in between. I draw a line that is a pretty straight line. So people think we are connected directly from here to here. We can connect directly or through some other routers. So either physically we are connecting or logically we are connecting. Once again, guys, what is the network? Interconnection of two or more devices is called network. Communication between two or more internet connected devices is called networking. Interconnection of two or more different networks is called internetwork. That is internetworking, communication between different networks. Okay, guys, understand these four lines. Nothing. Okay. No one is told anything. We'll continue. Guys, here I am use a device called hub, or we can use switch. Depends upon the size of network and requirements. Okay. So using this switch or hub, I can able to create a network. Simple. I create a network. Here it is. A network is created. Okay. The router. So we are using here. The router is an internetworking device which make a communication between this network to this network. Okay. So guys, you connected devices. So physically, we call it as a network. Connection of two or more devices. Interconnection of two or more devices is network. It means you connecting devices is a network. Okay. If you are communicating between the devices is networking. Okay. You can connect devices in different manner. You can connect the devices to a centralized device like a hub or a switches, or maybe you can connect one device to another device directly like this. You can connect it, or maybe you're connecting all the devices to a single cable. Okay, you can connect one device to another device, other device to another device. Like in different ways you can able to connect. Okay, different ways you can able to connect devices physically. So that type of network we call it as a physical network. It is nothing but a connection of devices. As I said, we can connect the devices different ways. That is, we call it as a physical topology. As network means, okay, either it can be a physical network or it can be a logical network. What is meant by physical network? The way you are connected the devices. Okay, you take 10 devices, you are connected them, and you have another 20 devices, you are connecting them. Like how you are connecting. So physical network and logical network. The physical network or physical topologies depends upon the way of devices connect. Logical networks are logical topologies based on the IP address configuration, based on the logical address configuration in it. Okay, so what are these physical topologies? It's a way of devices connecting. The devices can be connected in different ways. You have a device. Okay, so I have a devices. These devices are connected to a backbone cable. These devices are connected to a backbone cable. And these cables are mostly the coaxial type of cables. Here we are using, okay, coaxial cables. Okay, the cable types are we are using coaxial cable. You know, this type of connectivity we used for cable TV connection purposes. In olden days, so we have a cable TV. So from a cable TV guy is there, he has his own satellite kind of stuff. From his home, so from his station, he will run a big cable over the houses. And from houses, again, he will connect another wire to the TV. Okay, so later we got a set-up box kind of stuff. Now compulsory, everybody is max to max. We are using this dish antennas only. Okay, so it's become better choice. Okay, backbone. There is a backbone cable. Devices are connected to a backbone cable. There is a AC and no cooling from it. Okay, so this model we call it as a bus topology. I think I'm disconnected. Recording is going on. No one is talking anything.
Yes, sir, we can hear.
Yes,
You
just
are
if
audible,
you
sir.
then okay. Okay, devices connected to a backbone cable. Okay, and the devices are communicating through this backbone cable only. So A is communicating to B or C. It has to go through this backbone cable only. All the communications has to be go through this backbone cable only, and it is very easy to configure. Okay, and lower cost effective. Lower cost effective. But there is a flaw. It is if any cable is broken, the main backbone cable is transferring your data, right? If cable is broken at a certain points, further communication will stop. Further communication will be stop, and you have to investigate where the cable got a problem. So then you have to go through entire cable tracing. So then you have to find it and repair it. So it has become little difficult to troubleshoot. It is easy to configure and cheaper solution, but little difficult to troubleshoot. Plus, all the data is transferring to this cable only. So there is a possibility of packet collisions also there. It's not as fast as what we are using the topologies. That's not one. Okay, because all the data has to be transferred to that cable only. And of course, still we are using this backbone cable concepts in the tree topologies or in a fiber optical networks we are using it, but still in a LAN networks in general regular communication places we are not using bus topologies. Okay, what is a bus topology? It is all the devices connected to the a backbone cable and communicating through this backbone cable only. Easy to configure and cheaper solution and difficult to troubleshoot. And another type of topology is like this. Here in this one, the devices are connected to another device. One device is connected to another device. Other device is connected to another device. Another device is connected to another device. Finally, the last device is connected to the first device. Okay, it's created a loop, means a closed loop kind of stuff it is created. A device is connected to another device, a device is connected to another device, like that. Okay, but how it will be communicated, how it will transfer the packet. For example, A want to communicate it to B, D. A will send a packet to B, B send a packet to C, C send a packet to D. Now D is replying. Okay, D is going to reply to it. So D send a packet to E, E send a packet to E. See how many steps? One, two, three. Three steps required to reach from A to D. From D to A, only one step or two steps, it is reached. Okay. So its meaning is it will communicate either clockwise or anti-clockwise. So if you follow the clockwise like this, anti-clockwise in reverse manner. Okay. It is called a ring topology. It is called a ring topology. What is a ring topology? One device is connected to another device and other device is connected to another device. And as per ring topology, it uses a special algorithm. So then you have to configure to each and every device so that how they will communicate, how they will transfer the packet kind of stuff. Okay. So depends upon the destination. And what is the fly here? It is if in case a cable is broken, so further communication will stop. A to B, that's it. No B to C. Even a device is down, that's it. No communication, no further communication. One-way communication, another communication. Of course, it is look like easy to configure, but there is a lot of work. of algorithm kind of stuff. It means if I want to add one more device, again you have to configure everything how data should be transferred from one device to another device. Okay, next. As I said, clockwise or anti-clockwise, if you are using one type of thing, it has become difficult to transfer the packet to the destination. And that's why there is a solution. They made it that is called a double ring. Means each device is connected with a two cables like this. Now it is called a double ring topology. One side it will communicate in a clockwise. For example, A to D. So it use anti-clockwise. It is easy. C to B or C to B or C to A. So it is quite easy. In other side, A to C from here to here. Means it will communicate both clockwise and anti-clockwise because we defined two paths here. Okay, that is called a double ring top. So what is a ring topology? A device is connected to another device, other device is connected to another device. Totally it is created a final loop, final device is connected to first device. It transfers the data from one device to another device. In case of a wire is broken between them or maybe a device is down, so further communication will stop. And it is very difficult to troubleshoot because you have to find where is the broken issue is occurring and we have to repair it back. This is a ring topologies. Okay, sorry, still picture is still. This is a device is connected to all other devices. The device is connected to all other devices. One device is connected to all other devices. So here it is connected to B and C and D and E. So one device is connected to all other devices. Just in case, if this wire is broken, it means A to B communication stop. But remaining communication is function. The device is down. Only that particular device is not communicating. All remaining devices will communicate each other. So this topology, what is the topology type it is?
Star topology.
It's
Mesh
a mesh
topology.
topology. Okay. So because it's look like a one we are writing, so it is showing like a star. That is for easy to writing purpose. People put a star first. Okay, that's it. It is a mesh topology. Each and every device is connected to all other devices. It is a complex network because we are using a lot of cables. If you want to add one more device, it's very big, difficult to add because every device required some NIC to connect it, right? Again, you have to go to each and for example, already 10 computers are there. We brought another 11th computer. You have to go to each and every system to get a cable connected to the 11th one. It is very difficult or a complex configuration it is. But it is redundant. Why redundant? One cable is down, still no problem. One way or other way, devices will connect. The device is down, no problem. All other devices are connected and communicating each other. So where we use this mesh topologies? In generally our local LAN networks, we are not using. Mesh topologies especially used in high places like mm, core routing parts, server rooms, SAN storage types. We use this mesh topology. Means we connect to one server to another server, other server to another server, one server to multiple servers, like that. Okay. So storage devices, switches we use in SAN also will be connected like that only. So that is a mesh topology. Mesh topology is a complex, and but it is redundant. Means the device or a wire is broken, still there is a communication. In this topology, the devices are connected to a centralized device. A device is connected to a centralized device. Okay, the centralized device can be a hub, can be a switch, like that. Okay, so this centralized device. So accept this topology. So all previous three topologies we use only cable connection, but this is we are using a centralized device. Either it can be used hub or we can use switch. Devices are communicating through this centralized version. For example, A to B communication, A send a packet to the switch, switch will give packet to the B. Okay, so it is very easy to configure and easy to troubleshoot. Why? Because of these switches having LED statuses, cable status, connectivity status, LED status is there. So by looking at where is the issue is occur, we can able to guess. Next one. If a wire is broken, only this particular device is unable to communicate with others. A system is down, it means only the particular device system is unable to communicate. Okay. So we use hub or a switch as a centralized device to connect the devices together so they can able to communicate each other. All the communications we should go through this hub or a switch on. Okay. It is very easy to configure and easy to troubleshoot. Okay. So this topology we call it as a star topology. And it has another thing it is we can extend this star topology. For example, I have a devices are connected to another switch and to make them connect each other and communicate into a system kind of stuff. So then you can connect this hub or switches to another hub switch. Earlier both are different segment network. Now everything is same network. Okay. Now it can be a hub or switch. I use it. Okay, and you are connecting this hub to switch. So now both devices are in the same physical and logical network. Okay, this type of topology we call it as a extended topology. Yeah. So here it is, a bus topology. Devices connected to the backbone wire. Ring topology, one device is connected to another device, other device is connected to another device. Finally, the last device is connected to the first device. Mesh topology, one device connected to another device, other device is connected to another device. Sorry, one device is connected to all other devices. It is a mesh topology. What is a star topology? there is a centralized device. All the devices are connected to the centralized device. And even though one cable or maybe one system is down, still we can able to connect and come. Okay. Point to point, when you are communicating one device to another device, it's a kind of point to point. And another way we can able to say, guys, if you are in your organization is connected to your branch office, head office connected to branch office, that is point to point. But head office having lot of branch offices, point to multi-point connectivities. That is okay. So these are the physical topologies: bus topology, ring topology, mesh topology, and star topology. Okay. This is tree topology. Different topologies are connected to same single backbone line. Like a tree, trunk, these are the branches. Okay. Understand, guys, what is a network, what is networking, and what is a physical network or physical topologies? What are the different topologies you have? Hmm? Take a break for 10 minutes. Don't sleep, guys. Have some tea or coffee. Come back by 3:30. 3:30 if I take more time. So more than 10 minutes it is I'm giving. So come back at 3:30.